Here we're doing the assignment quadratic functions and parabolas. And we're on the first page, we're just reminded of the parent function with the parabola that looks like this, or vertex at 0, 0, and that width. And we have the standard form of a quadratic function and the vertex form of the quadratic function. The vertex form is handy when we want to graph it because we can see the vertex in the equation of hk. And we can't see the vertex in standard form. In standard form, we have ABC. That's great if we want to express it as a polynomial to combine with other polynomials, or if we want to use a quadratic formula to solve for it. But the vertex form helps us graph it and see the shape and location better. So here we have a amusement park that has a roller coaster that has been unsuccessful. Guests have said that they think the climb hill is too tall and too fast. And so they're aiming towards families, but maybe families don't like it, and that's what the family's feedback has been. So they hired a Galaxy Fair amusement park. They hired a redesign company to redesign the roller coaster, which is called the Twist. The original formula or quadratic equation that describes the climb hill is that f of x. And the company that is redesigning it is proposing this equation for this climb hill. So we're going to explore these two equations and what those climb hills look like. The task is to rewrite both of these equations in vertex form. So they didn't give us too much space to do that, so I'm going to show my work on the other one. That means we need to take that standard form of the equation that they've given us, whoops, these two equations here in yellow and green, and complete the square and get it a vertex form. So I'm going to copy those down on a separate page. And I'm going to say, I'm just going to put a little note here, see work on next page. And we'll bring it back to this front, bring our final answer back to page 1, but let's show our work so we have some space here. So f of x is negative 0.10 x squared plus 3, let's see, I think it was 3.6 x minus 24, I think. Let me go back. 0.24. Okay, and the hint that they gave us is that each function has a common factor. So the common factor here is this negative 0.10. So I can, if I divide each piece by that, then for that first piece, so I'm going to take out the negative 0.10, I just get, if I divide that first, so I'm dividing each piece by negative 0.10, then that would cancel that, and I just get x squared for the first term. For the second term, when I divide by a negative, I get a negative, and divided by 0.10, and one way to divide by a decimal is you can just move your decimal over. If I move it right 1, then I just have the number 1 in the denominator. So I'm going to, whatever I do on the bottom, I got to do on top, so I really just have 36. So that gives me 36x in my second term. Same idea for that last term of 2.4. I'm going to divide by a negative, so that makes this third term positive. And I'm going to divide by 0.10, which means move that decimal over 1, and I get 24. All right, now the next step is I want to complete the square to get that vertex form. Remember our vertex form, just to remind you of our goal here, our vertex form looks like this. It's going to have something out in front, that's our A, and then it has x minus h squared plus k. So I know I need a perfect square there. So I'm going to try to get this to be my perfect square. So I can see that a is going to be negative 0.1, but I still need to figure out what the h and the k are. So I need to separate this information. It looks like that 24 is going to go towards the k, and I need to make a perfect square in the middle there. So I'm not going to do anything else with this a piece in right now, so I'm just going to copy it down. And I know that I need to get a perfect square in here, so I'm going to do x squared minus 36x, and to make it a perfect square trinomial, I have to add something else. And whatever I add, and I'm going to bring that 24 outside the parenthesis. Remember, this is all inside brackets because that negative 0.10 is out in front of everything. So plus 24, whatever I add here, I need to subtract here. So I'm going to balance what's in there. I don't want to change the value. So to figure out how to complete the square there, I take that 36, or that middle term of this quadratic that I'm trying to complete the square on, take the middle term, divide it by 2 and square it. So that's 18 squared, which gives me 324. And whatever I add here, I got to subtract over here so I don't change the value. So now I have a perfect square trinomial. This right here is a perfect square trinomial. So when I factor that, I get x minus 18 squared. And I still have out in front that negative 0.10. I'm just copying that part down. Same with that plus 24 minus 324. Actually, I'm going to actually go ahead and simplify this part too. So we factored this piece and we got that. And now I'm going to simplify this thing. And I get 24 minus 324 is a negative 300. A lot like our vertex form. However, the vertex form doesn't have these brackets with that a out in front of everything. A is not attached to the k at all. So I'm going to distribute. And whoops. I'm going to distribute. So I'm going to take that negative 0.10 and distribute it to this term and also to the second term. I don't need to distribute it into the parentheses for that first term because notice that a is out in front of that squared binomial. So for that first term, I can just write negative 0.010 times x minus 18 squared. So that's distributed to the first term. And then the second term, I'm going to multiply that by 300. So negative 1.0 times negative 300 gives me a positive 30. Remember, move our decimal once to the right. And we're dividing. So this one will go once to the left. So I get that 30. And then that is my original roller coaster climb hill equation. So that's our f of x in vertex form. So I'm going to take that equation and put it back up in for number 1. So that was f of x. So f of x I'll do in blue here. And then we got to go back and do g of x. And again, I need that space on the second page, so I'm going to go ahead and use that second page. On my magic paper, I'm going to go ahead and shrink this up so I can just have them together on the same screen. If you need to use a second page, please do so. Don't try to squish your work where it doesn't quite fit. All right, so our g of x function was negative 0.03 x squared plus 1.62x minus 6.87, I believe. Okay, and we're going to complete the square to get vertex form here. Again, our goal is to make it look like this. So our goal is to look like something with an A in front, a perfect square here, and then a constant at the end. So, and our hint again is to take out the common GCF. So that is this thing right here. That's our GCF. So I'm going to factor that out. And the first term I get x squared. This time it's a little trickier to, I'm going to divide every term by negative 0.03. It's a little trickier to do without a calculator because it's not as easy as moving a decimal. You got to actually divide by 3 also, or you can use a calculator. So just put 1.62 divided by negative 0.03, or think about moving the decimal 2 places and also divide by 3. That will give you 54x here, and that last term, move the decimal over twice and divide by 3 gives you 229. Oh, and change the sign because we're dividing by a negative. Steps we did an F, as I want to put them on the same screen. So remember what we did was complete the square and separate that constant that's going to become the K. So that 229 is going to go into the K, and I'm going to complete the square using the first two terms of this. So I'm going to write the first two terms, close it, and then finish it. I have a bracket around all of that because that negative 0.03 is in front of everything. And whatever I add here, I'm going to subtract, actually inside the bracket. Everything's inside that bracket. Subtract here. All right, so what do I put there? Well, I take that middle term, the B term, and divide by 2 and square it. So that's 26 is 13. 13 squared gives me 729. Whatever I add here, I subtract there. And then I'm going to factor this part and simplify this part. So, and then this negative 0.03 just goes along for the ride. And I still have brackets right now because brackets around everything because I have that negative 0.03 in front. So factoring that perfect square trinomial, I get x minus 27 squared. Next group, 229 minus 729 gives me negative 500. All right, and now I'm going to distribute this guy to both of these pieces. To the first piece, that's x minus 27 squared. And when I distribute, I can get rid of my brackets. And then 0.03 multiplied by 500 gives me a positive 15. Negative times negative, and then 3 times 500. That's moved over. All right, I think we're done with g of x now. So here's the proposed function. But that's what the design company is proposing. So I'm going to bring that up to the front to number 1, put my final answer right here, and I brought a note to see my work on my next page. Definitely want to show all that work, but it's a little hard to squeeze in here, so I'm going to do it like this. And make sure you show your work. You can use a separate page to make sure you have space. All right, moving on to number 2. We're looking for the vertex of each function. And now that these are in vertex form, remember our vertex is the opposite of the h, this minus h, and then k. So our vertex is going to be, going from here, I can see from this equation, my a is going to equal, I'm going to do this in blue because f of x is in blue. So my a is negative 0.10. I can see my h. My h is opposite of whatever's there. So that's going to be well, negative 18 becomes positive 18. And my k is 30. Whereas my g of x function, I have a equal to, that's coming from here, negative 0.03, and my h is that 27, and my k is 15. That means my vertex, which is hk, is 2715 for g of x, and hk and the f of x function is 1830. So there's my vertices. So let's see. The vertex of f of x is 1830, and I can see that from the equation right above, which means in context means it bring back to the scenario, the story, the reason we're doing this, which is the roller coaster, the twist. So the vertex of f of x is this, which means that, and let's go find out what x and y are. So f of x, x, these functions represent the climb hill, where x represents the time in seconds, and y is the height of the roller coaster in feet off the ground. So x is 18 here, and y is 30. So that means after 18 seconds after leaving the station, the roller coaster is 30 feet off the ground. So that means that 18 seconds after the coaster leaves the station, it reaches, and it's not just that it reaches that height, but it's actually the apex, because we did say it's the vertex, which means our parabola looks like this, and this spot right here is that vertex. So it actually doesn't just reach 30 feet after 18 seconds, but it reaches its apex, which is 30 feet. So it reaches its apex of 30 feet high. It's as high as it goes after 18 seconds. All right, so the roller coaster takes 18 seconds to get 30 feet, and then it starts coming back down. Okay, what about g of x? What does this one tell us? Let's see. Here in g of x, that's our time and that's our height. So after 27 seconds, I don't think I wrote that right. Sorry, I think I copied the wrong equation down. That should be a 15. After 27 seconds, or else that'd be a very high roller coaster. It reaches a height of 15 feet. So looking at f of x, that one had after 18 seconds, it got to 30 feet, and that was the apex. Our new proposal, after 27 seconds, it gets to 15 feet. So we can already see the roller coaster is going slower. It takes longer to get to the apex, and the apex is not as high. It's only half as high now, from 30 to 15. So we're getting an idea of what they're doing, and the two functions that we're looking at here. The vertex is lower. The apex of the roller coaster is lower, and it takes longer to get there. So the vertex of g of x is 2715, which means that the roller coaster, the twist, will reach its apex at 15 feet high Actually, I shouldn't change that word to of, because at usually means like at what time. So an apex of 15 feet high at 27 seconds after leaving the station. So we can see it's already going slower and not as high. All right, now in number 3, we're comparing the a value of the f function. So that's the one on the left. We're just looking at the f of x function. That's the original roller coaster. To the a value of the parent function. So that parent function is, the parent function is y equals x squared. And f of x, the function, equals negative 0, 1.0, x minus 18 squared plus 30. So our a value is, for the parent function, is 1. The a's 1 in that function. And the a value for f of x is negative 0.10. So that sign tells me that this parabola is opening downwards. And the a being a fraction, or just 1/10 of 1, tells me that it's going to be compressed vertically. Remember, the a in front tells me my vertical stretch or compression. Since it's less than 1, it's a compression, which makes the roller coaster or the parabola wider. As you compress vertically, imagine if I push down on this, what happens is it gets wider. So my parabola is getting wider as I compress it down as that fraction in front. So the a value determines the direction. So a value determines the width and direction of the parabola. So the of negative 0.10 means that in comparison to the parent function, which has a value of 1, The parabola opens down and is stretched wider. Trying to think about how to make more space here. And it's stretched wider and shorter. It's got a vertical compression than the parent function. Both the functions f and g on a single xy plane and describe the steps we took to create the sketch. So we could graph it on Desmos and just go to Desmos and enter those functions in, or we can graph it by hand. I'm going to use the vertex. I'm going to plot the vertex first for each of these, and then use an XY table and symmetry to graph to sketch. So I'm not going to make a perfect graph, but to sketch a graph. So I'm not going to get too picky because I'm going to make a sketch. So I'm going to start by creating myself some graph paper here. I wish I had actual graph paper, but I'll do the best I can with my blank white paper. So I'll make a little coordinate plane here. I'm only graphing quadrant 1 because, remember, x is time in seconds, and y is height in feet. And our roller coaster never goes back in time and it never goes underground. So it's x and y are always positive in or the part of the parabola that we care about is positive. That is the climb hill. So I don't need the other quadrants. I just want to know what the parabola looks like in that first quadrant. So I'm just going to do it like that. And then looking over at the vertices, 1830. So I know it's going to go, and then this one's 2715. So it looks like neither of them go above the height of 30. So I can make my y-axis 30 and cut that in half to make 15, and then try to cut that into thirds. I'm going to try really hard to make it equally scaled. This is where graph paper would come in handy. Just kind of eyeballing it the best I can. All right, and for the x-axis, let's see. I see, looking again at my vertex, the middle of the parabola is going to be at 18 and 27. So I'm going to make it about 50, because if the middle of the parabola is at 27, then the far right of the parabola might be at like 54. So I'm going to go to 50 here and 0, and then halfway between 50 and 0 is about 25. Try to split that equally into 5 pieces. That didn't work very well. I'm going to go a little bit bigger. I'm not loving my scale here. Okay, that looks pretty good. 30, 35, 40, 45. Again, this is a sketch, so I know those numbers are not exactly perfectly distributed, but I'm going to do the best I can. So I have a fair representation here. So starting with my vertex, that's at 18, 30. So x equals 18, about there. And my y is 30. So that's about there. So 18, 30. I know it's facing down. My parabola I know goes down because it's got a negative out in front. A is negative. So to figure out how wide it is, I'm going to do an XY table. So I'm going to go back over here to my function, which is right here. I'm going to make a quick XY table, and I just want to go like left and right of the vertex. So let's see, if my vertex is at 18, let's plug in 10 and see where it plugs in, where it lands, what the y value will be when x equals 10. So I'm going to plug in a 10 right here and see what I get for y.